but if you look at the unit circle, I want you to look at three angles. Pi over 6. What we know is that the cosine value is radical 3 over 2. Sine of pi over 6 is 1 over 2. If you look at pi over 3, cosine pi over 3 is 1 over 2. Sine pi over 3 is radical 3 over 2. And if you look at this angle, 3 pi over 4, cosine is negative radical 2 over 2, sine is radical 2 over 2. It's useful for you to look at your unit circle and see that those are the actual values. I'm going to write them down again. Remember that in these ordered pairs, the first number is the cosine of the angle, the second number is sine of the angle. Alright? Okay, so the first example. So we've got a sun directly overhead. Ravi is flying a kite. The length of the string is 50 meters. And when the sun hits the kite, it creates a shadow. We call this point x1, and we'll call this height y1. The string is 50 meters, that's 90 degrees. That's Ravi. So the first question says, what is the exact expression for the horizontal distance that the shadow of the kite moves? So here's the shadow of the kite at the beginning of motion. And then what happens is the wind picks up. So presumably the wind is blowing this way. And as the wind picks up, this kite starts rising up. So it winds up somewhere over, I don't know, let's say there. The length of the string is still 50 meters. But because this angle has changed, so my first angle was pi over 6. Last year we would have said 30 degrees, but it's pi over 6, the smaller triangle. And when the wind comes up and this kite flies up with the wind, that big angle is pi by 3. And the question is, see this second kite here? Okay, so I'm going to make it this dash line, and at that point I'm going to call that x2. This vertical distance would be y2. There's a 90-degree angle there. The book wants us, or the question is asking us for this distance. How far did the kite's shadow on the ground move from here to here? So that would simply be x1 minus x2. Okay, so it's important to figure out, okay, so this is what the question's asking us for. Give me an exact expression for x1 minus x2. I looked at my first triangle. My first triangle looks like this. I've got x1, I've got pi by 6, I've got 50, and so I know I can say that cosine pi over 6 is equal to adjacent x1 over hypotenuse 50. Pi over 6 is a special angle, so I can see from my unit circle that the cosine of pi over 6 is exactly radical 3 over 2. So I solve this expression for x1. To do that, I'm going to take this fraction and multiply by the denominator of x1. So that's 50 multiplied by radical 3 over 2. So you have to simplify this. 2 divides into 2 once. It divides into 50 25 times. So what you're left with is x1 is equal to 25 radical 3. A similar thing for the other triangle. So that's pi by 3. This is x2. This is 50. And we can say that cosine of pi by 3 is equal to adjacent x2 over hypotenuse. To solve for x2, I'm going to multiply the other side by 50, but first I need this. You see pi over 3, special angle. If you look at your unit circle, you'll see that the exact value for the cosine of pi over 3 is 1 over 2. So to solve for x2, x2 will be 50 times 1 divided by 2. So x2 is equal to exactly 25. So the question said find an exact expression. So that's why we were looking for x1 and x2. And at this point what we've done is we found values for x1, we found values for x2. So now what we can do is answer the question. So x1 minus x2 is equal to 25 radical 3 minus 25. You think about this, this is like 25 times radical 3, this is like 25 times 1. So you could factor it. 25 times radical 3, 25 times negative 1. This is the exact expression that part A asks. This is in meters. Part B says find out what this expression is as a numeric value. Correct to 1 decimal place, so the nearest tenth of a meter. So if I do radical 3 minus 1, I get 0.732. I multiply that by 25, I get 18.3. So this part here, exact expression. This part here, approximate. The decimal place is a tip off. Just in case any of you got lost in that example, take out your unit circle and look at these 2 points. The first time the kite was over here. Okay? And so when the kite was over here, you were looking at the cosine of pi over 6. The cosine of pi over 6, radical 3 over 2. That's where I got radical 3 over 2. The x value is the cosine value for this angle. In the second part, when the wind blew the kite higher, it wound up at this angle, pi over 3. And the cosine of pi over 3 is 1 over 2. That's where I got those exact values. Sticking with that notion, the second question asks us for 3 pi over 4. You look at your unit circle there. The cosine of 3 pi over 4 is negative radical 2 over 2. The sine of 3 pi over 4 is radical 2 over 2. So right away you've got two exact values. You've got the sine, you've got the cosine, and then we can use that to find tan and so on. Okay? So from our unit circle, we've got these values. So what I can say is, I'm going to say it this way. I'm going to say sine 3 pi over 4 is equal to radical 2 over 2. Cosine 3 pi over 4 is equal to negative radical 2 over 2. That's it. It came right from the unit circle. So my third one is tan. Tan is sine over cosine. So if I do sine over cosine, I've got radical 2 over 2 divided by cosine. So sine divided by cos. Okay, so a little refresher on fraction division. First of all, there's two ways to look at it. The easy way is the same quantity divided by its negative is just negative 1. But if you need a refresher on your fraction multiplication and division, it's the top fraction multiplied by the bottom fraction flipped over. So that cancels, and you get negative 1. So cosecant of 3 pi over 4, that's going to be 1 over sine 3 pi over 4. So that's going to be 1 over. So sine 3 pi over 4 from your unit circle is radical 2 over 2. So when you take the reciprocal of that, what you're going to wind up getting is 2 over radical 2. So 2 over radical 2 is going to simplify. Two over radical 2 is going to simplify to radical 2. There's a couple of ways you can think of that. One way is, if you have radical 2 times radical 2 on the top, and you have radical 2 on the bottom, radical 2 times radical 2 is how we got this 2, and this radical 2 is just there, so you can see that if these two cancel, you'd be left with just radical 2. Another way to look at it is, if you have 2 over radical 2, we don't want to leave that radical there, we want to rationalize it. So you're going to multiply by radical 2 over radical 2. What happens? Well, 2 times the radical 2, this radical 2 and this radical 2 multiply to give us 2. These cancel, and again you're left with radical 2. So the cosecant of 3 pi over 4, radical 2. We've got secant of 3 pi over 4. So secant is 1 over cos. From your unit circle, the cos of 3 pi over 4 is negative radical 2 over 2. When you flip that over, you'll get negative 2 over radical 2. So just like in the previous situation, you've got negative. That top 2 is like radical 2 times radical 2. The bottom is like radical 2. When they cancel, you're going to have a result of negative radical 2. That's the secant of 3 pi over 4. We've got one last left. That's the cotan of 3 pi over 4. So cotan of 3 pi over 4, that's going to be 1 over tan 3 pi over 4. And earlier we found that tan of 3 pi over 4 was negative 1. And 1 divided by negative 1 will be negative 1. And again, those are all exact values. There's no decimals, there's no approximations.